A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Imagine you are trying to manage a high-stakes construction project, but your lead architect only speaks architectural Italian, your foreman only understands technical German, and your site inspector has a memory that resets every 50 words. That is essentially the headache waiting for you when you step into the world of multi-model agentic systems. It is one thing to use a polished single-vendor tool like Claude Code, but it is a completely different beast when you start mixing Anthropic, OpenAI, and open-source models like Qwen or Mistral into a single workflow.
It really is the Wild West of orchestration right now. Today's prompt from Daniel is about exactly that, the practical realities of building these heterogeneous agentic systems. We are moving past the era where you just pick one God model to do everything. Instead, we are seeing the rise of server-side frameworks like LangGraph, CrewAI, and AutoGen that let you treat models from different vendors as specialized workers. But as Daniel points out, the interoperability gaps are where the wheels usually fall off. By the way, if the flow of this conversation feels particularly sharp today, it might be because Google Gemini 3 Flash is actually writing our script.
I was wondering why I felt so efficient this morning. But look, let's frame this properly. There is a massive divide between what I call the walled garden agents, things like Claude Code or OpenAI's specialized wrappers, and these model-agnostic frameworks. If I am using Claude Code, I am staying in Anthropic's house. Everything is tuned for Claude's specific way of thinking, its XML tagging, and its massive context window. But if I want to use a LangGraph setup where a Claude orchestrator delegates a subtask to a local Mistral model or a specialized Chinese model like Qwen 2.5 for specific data extraction, am I just asking for a nervous breakdown?
Herman Poppleberry here to tell you, not necessarily a breakdown, but definitely a lot of manual labor. The core question is whether a frontier model like Claude 3.5 Sonnet can effectively boss around, a model it wasn't co-trained with. When you stay within one vendor, the models share a language of sorts. They've been RLHF'd reinforced learn from human feedback to follow similar instruction patterns. When you go multi-vendor, you hit the instruction gap. Claude might send a beautifully formatted request wrapped in XML tags because that's what it's good at, but the worker model, say a smaller Mistral 7B, might have no idea what to do with those tags. It might just ignore them or, worse, get confused and hallucinate a response.
It's like sending a Slack message with fancy markdown to someone using a pager. The content is there, but the formatting makes it unreadable. So, if we're looking at the big frameworks, LangGraph, AutoGen, CrewAI, how are they actually handling this? Because they all seem to have a different philosophy on how much they should intervene between the models.
They really do. LangGraph is probably the most hardcore engineering approach. It uses a state machine logic where the framework itself holds the source of truth in a persistent database. It doesn't rely on the model to remember everything, it just feeds the model the specific slice of state it needs at that moment. CrewAI, on the other hand, leans into role-playing. It wraps every model in a persona. If you tell a Qwen model, you are a world-class Python debugger, the framework handles a lot of the heavy lifting to make sure the instructions are formatted in a way that Qwen understands. Then you have the Model Context Protocol, or MCP, which is the big industry push right now to create a standardized USB port for these agents so they can share tools regardless of who built the brain.
Okay, so the USB port logic sounds great in theory, but let's get into the technical weeds, because this is where people actually get stuck. Let's talk about context windows. This feels like the most obvious point of failure. If I have a Claude orchestrator with a 200,000 token context window, and I'm asking it to manage a local Mistral model that only has a 32,000 token window, That's a recipe for disaster, isn't it?
It's the drowning problem. Imagine the orchestrator has read the entire history of a project, every email, every line of code, every meeting transcript. It has all 200,000 tokens in its active memory. Now, it needs the worker model to write one specific function. If the orchestrator just dumps its entire context into the worker's prompt, the worker literally cannot fit it. The API will return an error, or the model will simply forget the beginning of the instructions to make room for the end.
So the worker model is basically a goldfish being asked to summarize war and peace.
Well, not exactly. I'm not allowed to say that word, but you've hit the nail on the head. The practical fix that people are using in March 2026 is something called summary buffers, or mission briefs. You cannot just pass the conversation history. You have to program the orchestrator to perform a MapReduce style operation. Before it talks to the smaller model, the orchestrator has to summarize the state into a condensed high-density prompt that fits within that 32K limit. If you don't do this, you hit the lost in the middle phenomenon. Research has shown that even if a model claims to have a certain context window, its performance degrades significantly in the middle of that window. When you mix models, the weakest link defines the intelligence of your entire system.
That's a huge point. If your worker model is struggling with a 32K window, your 200K orchestrator is effectively neutralized. It's like having a CEO who knows everything but can only give 5-second instructions to the staff. You lose all that nuance. And it's not just the size of the window, right? It's how they use it. I've seen cases where different tokenizers cause issues. If I'm calculating my context limit using Claude's tokenizer, but the worker model is using the Llama 3 tokenizer, my math is going to be off by 10 or 15%.
That is a classic trip-up. Tokenization mismatches are the silent killers of agentic workflows. If you are writing the edge of a context limit, 15% is the difference between a successful completion and a truncated JSON object that breaks your entire parser. And speaking of parsers, let's talk about the output formats. This is the #1 cause of system failure in multi-model setups. Anthropic models are trained to love XML. They want things in tags. OpenAI and most open source models like Mistral or Llama are heavily optimized for JSON. If your orchestrator is expecting an XML response because it's a Claude-based system, but your worker is a fine-tuned Llama model that outputs JSON, the handoff fails immediately.
I've run into this. You get these hallucinated tags where the model tries to compromise and gives you some weird hybrid of JSON inside an XML tag, and the regex you wrote to clean it up just dies. Is the solution just to be more rigid with the prompting?
The real-world solution is to stop relying on vibes and start using validation libraries like Pydantic or Instructor. You need a validation layer at every single handoff. When the worker model responds, the framework shouldn't just pass that text to the next agent. It should run it through a schema check. If it doesn't match the expected JSON or XML structure, it should automatically loop back to the worker with an error message saying, "Hey, you forgot the closing tag," or "This isn't valid JSON." This adds latency, but it's the only way to get a multi-vendor system to be reliable enough for production.
It's basically adding a middle manager whose only job is to check the paperwork before it moves to the next desk. It sounds tedious, but I guess it's necessary when you're dealing with different cultures of AI models. Now let's talk about the knobs and dials, the technical parameters. Temperature, top P, all that stuff. Does a temperature of 0.7 on a Mistral model actually mean the same thing as 0.7 on GPT-4o?
Not at all. This is one of the most misunderstood parts of LLM engineering. Temperature is a scaling factor for the probability distribution of the next token. But because every model has a different vocabulary and a different distribution of weights, the effect is totally inconsistent. A 0.7 on a smaller, punchier model might result in total gibberish, while on a massive frontier model, it just feels creative. In a multi-agent system, the best practice is to standardize. Usually, you want your worker agents, the ones doing data extraction, code generation, or logic, to be at temperature 0. You want them to be as deterministic as possible. You only let the orchestrator or the creative agents have a higher temperature for routing decisions or brainstorming.
That makes sense. You want the boss to be the one with the big ideas, and the workers to just follow the blueprint exactly. But what about system prompt sensitivity? I've heard that some of the newer open source models, especially the Llama 3.1 and 3.2 series, are incredibly picky about where you put the instructions.
They are. Some models treat the system rule like it's the Bible. They follow it above all else. Others, especially some of the Qwen variants from Alibaba, actually perform better if you put the core instructions in the user role or a developer role. If you use a framework like CrewAI and you give every agent the exact same system prompt, you're going to get wildly different results. The Claude agent will be polite and verbose. The Llama agent might be terse and aggressive. The Qwen agent might ignore half the instructions because it's looking for a different prompt header. To fix this, you have to use model adapters. LangGraph released a system for this in January 2026 that basically detects which model is being called and automatically reshuffles the prompt into that model's preferred structure.
It's like having a translator who knows that when you talk to the German foreman, you need to be very direct, but when you talk to the Italian architect, you should start with a compliment. It's social engineering for AI models.
That is a great way to put it, and we haven't even touched on the geopolitical and logistical side of this. If you're building a system that uses Claude for the heavy lifting, but delegates to Qwen for Chinese language tasks, or Mistral for local, privacy-sensitive tasks, you're dealing with different API providers, different latencies, and different cost structures. You might have a race condition in an asynchronous framework like AutoGen. If your fast local model finishes its task in 200 milliseconds, but your frontier model takes 5 seconds to respond, your orchestration logic has to be robust enough to handle that jitter.
Right, because if the orchestrator is waiting for a piece of data that the fast model already provided, but the system isn't designed to check the mailbox constantly, you're just wasting time. It's the classical distributed systems problem, just applied to brains instead of databases. Let's look at a case study to make this concrete. Imagine we're building a research agent. Its job is to take a massive document, summarize it, and then check those summaries against a database of Chinese language patterns.
Okay, perfect scenario. For the summarization, you want Claude 3.5 Sonnet. It has that 200K window, it's great at nuance, and it doesn't miss details in long documents. So that's your orchestrator. But then you need to check Chinese patents. Qwen 2.5 is objectively better at that than almost any Western model right now. So you have a LangGraph node that sends a snippet of the summary to Qwen.
But wait, here's the problem. Claude creates this beautiful structured summary with a lot of cross-references. It sends that to Qwen. But Qwen's context window is smaller, maybe 128K. If the summary is huge, or if the orchestrator includes too much meta-conversation in the prompt, Qwen might get overwhelmed. Plus, if the orchestrator uses a specific internal naming convention for the patterns, Qwen might not get it, because it wasn't part of the original training data.
And this is where the instruction gap hits. Claude might say, please analyze the following patents and use the patent refs tag for each citation. Qwen might just ignore the patent refs tag and give you a bulleted list because that's what its base training prefers. If your downstream code is looking for patent ref, your system breaks. To make this work, you need a normalizer. Between Claude and Qwen, you need a small bit of logic, maybe even a tiny cheat model like a Mistral 7b, whose only job is to take Claude's output and repackage it into a prompt that Qwen is guaranteed to understand.
It sounds like a lot of overhead. Is there a point where we just say, forget it, I'll just use one model for everything, even if it's slightly worse at specific tasks?
That's the vendor moat argument, and for some people, the answer is yes. If you stay entirely within the Anthropic ecosystem, you don't have to worry about tokenizers or temperature differences or tag mismatches. But you're paying a convenience tax. You're paying more for tokens, you're locked into their latency, and you can't use specialized models that might be 10 times better at a specific niche task. The companies that are winning in 26 are the ones institutionalizing these interoperability layers. They are building their own internal model gateway that handles all this translation automatically.
So it's the classic build versus buy or integrated versus modular debate. If you want the best performance, you have to embrace the modularity, but you have to be willing to do the plumbing. Let's talk about some specific second-order effects that people miss. What about cost and latency? If I'm hopping between 3 different vendors for one user request, I'm paying 3 different egress fees, 3 different base rates, and my total, time to first token, is the sum of the slowest model's latency plus the network overhead.
The latency jitter is real. If you're using a framework like CrewAI, which is very chatty, meaning the agents talk back and forth a lot, the round-trip times can become unbearable. If agent A Claude talks to agent B Qwen, who then talks to agent C Mistral, you're looking at 10 or 15 seconds before the user sees anything. The pro tip here is to use asynchronous parallelism. Don't make them wait in a line. If the orchestrator knows it needs 3 things done, it should fire off prompts to Qwen, Mistral, and Llama all at once. LangGraph is excellent for this because you can define parallel nodes in your graph.
But then you have to merge those responses. And if Mistral finished but Qwen failed because of a weird API error, your orchestrator has to be smart enough to retry or fall back. This is where the complexity really starts to explode. It's not just about the AI anymore. It's about traditional distributed systems engineering. You need circuit breakers, you need retry logic with exponential backoff, and you need graceful degradation. If the Chinese pattern model is down, can the orchestrator try to do it itself, even if it's less accurate?
That is exactly what high-end AI engineering looks like right now. It's about building resilient swarms. And there's a cost-saving angle too. People think multi-model is more expensive, but it can actually be much cheaper. Why use a $2 per million token model to check if a string is valid JSON? You can delegate that to a local Mistral model running on a cheap GPU for practically zero cost. The best-in-class architecture is a router worker setup. The router is the most expensive, smartest model you can afford, like a Claude 3.5 Opus or a GPT-5. And the workers are the cheapest models that can pass the unit test.
Cheapest model that can pass the unit test. I like that. It's a very pragmatic way of looking at it. It turns the AI from an oracle into a utility. But to get there, you need those unit tests. You need to know exactly what success looks like for each subtask. You can't just say, go research this. You have to say, extract these 5 fields into this specific JSON schema.
And that is the secret sauce. If you can't define your agent's task as a unit test, you shouldn't be delegating it to a smaller model. The smaller models are great at constrained reasoning, but they fall apart on open-ended ambiguity. The orchestrator's job is to turn the user's ambiguous request into a series of highly constrained testable tasks for the workers. When you do that, the multi-model system becomes incredibly powerful. You get the reasoning of the frontier models with the speed and cost of the open source ones.
Okay, let's move into some practical takeaways for the listeners. If someone is sitting down today to build a multimodal system, maybe they're using LangGraph or they're experimenting with a new CrewAI setup, what are the first 3 things they should do to avoid these pitfalls?
Number 1, normalize your parameters at the framework level. Don't let your individual agents set their own temperatures or top p-values. Use a central config or a model adapter that ensures temperature 0 means the same level of determinism across every model in your stack. If you don't, you'll spend weeks chasing ghost bugs where one agent suddenly gets creative and breaks the pipeline.
Number 2, always, and I mean always, use a summary buffer for handoffs. Do not assume any model can see the full context window. Even if the docs say it has 100k tokens, treat it like it has 20k. Have your orchestrator write a mission brief for every delegation. It should include the immediate goal, the specific data needed, and the required output format. Nothing else. No chit-chat, no historical fluff. Keep the worker focused.
And number 3, implement schema validation as a first-class citizen. Use a library like Instructor or Pedantic to enforce your output formats. If a worker model returns something that isn't valid, JSON, don't let that error propagate to the next agent. Catch it, send it back to the worker with the error message, and let it self-correct. This reflection loop is the difference between a system that works 80% of the time and one that works 99% of the time.
I'll add a 4th one. Start small. Don't try to build a 10-agent swarm with 5 different vendors on day 1. Start with one orchestrator, Claude, and one worker, Mistral or Qwen. Get that handoff perfect. Understand the latency, the tokenization quirks, and the instruction gap for those 2 specific models. Once that's stable, then you can start adding more complexity. It's much easier to debug a 2-model system than a 5-model swarm.
That's a great point. It's the Gall's law of systems. A complex system that works is invariably found to have evolved from a simple system that worked. If you try to build a multi-model agentic hive mind from scratch, it will never work. You have to evolve it.
It's funny, we've spent so much time talking about how these models are changing the world, but at the end of the day, making them work together feels a lot like old-school systems integration. It's about protocols, schemas, and handling edge cases. The intelligence part is almost the easy bit. It's the communication part that's hard.
That's been the theme of tech for 40 years, hasn't it? We keep inventing more powerful brains, but the bottleneck is always the bus, the way those brains talk to each other and to the rest of the world. Frameworks like LangGraph and the Model Context Protocol are trying to build that bus in real time while the AI is already driving down the highway. It's a fascinating time to be an engineer.
It really is. And I think we're going to see a lot of these vendor-specific moats start to crumble as the open source models get better and the orchestration frameworks get smarter. If I can get 95% of the performance of a Claude-only stack for 30% of the cost by mixing in some Qwen and Llama agents, why wouldn't I? The economic pressure to go multi-model is just too high to ignore.
Oops, I almost said it again. You're right, the economics always win. We saw it with cloud computing. Everyone started on AWS, but eventually the big players moved to multi-cloud or hybrid cloud to optimize for cost and resilience. We're seeing the exact same pattern play out with LLMs, just at a much faster pace.
Well, this has been a deep dive. I feel like I need to go rewrite all my prompt templates now. Before we wrap up, let's look at the horizon. What's the next big thing in this space? Is it going to be models that are specifically trained to be good workers for other models?
I think so. We're already seeing distilled models that are specifically fine-tuned to follow the instruction patterns of frontier models. Imagine a Mistral Claude worker model that has been trained on millions of examples of Claude's XML instructions. That would solve the instruction gap overnight. And on the flip side, I think we'll see orchestrators that have internal world models of the workers they are managing. They'll know that Model X is bad at math, so I need to give it more step-by-step instructions.
AI emotional intelligence for managers. I love it. Even the robots have to learn how to manage their reports effectively.
It's managers all the way down, Corn.
On that terrifying note, let's call it, this has been an incredibly practical look at a very complex topic. Thanks to Daniel for the prompt. It really pushed us to look at the how rather than just the why. If you're building in this space, hopefully these tips on context windows, parameter normalization, and schema validation save you some gray hairs.
Big thanks to our producer, Hilbert Flumingtop, for keeping the gears grinding behind the scenes. And a huge thank you to Modal for providing the GPU credits that power the generation of this show. If you want to run these kinds of multi-model swarms yourself, Modal is a great place to do it. They handle the infrastructure so you can just focus on the logic.
This has been My Weird Prompts. If you're enjoying these deep dives into the guts of agentic AI, do us a favor and leave a review on Apple Podcasts or Spotify. It's the best way to help other curious minds find the show.
You can also find all our episodes, RSS feeds, and transcripts at myweirdprompts.com. We're always looking for new prompts, so if you've got a technical mystery or a weird AI theory you want us to explore, send it over to show@myweirdprompts.com.
We'll be back next time with another prompt from Daniel. Until then, keep your temperature low and your validation strict.
See ya.
This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow